Hello, my name's Keith Rucker, and today we're back out at the Georgia Museum of Agriculture, and once again I'm working on restoring this J.A. Vance planer matcher, built probably in the early 1900s, we're speculating based on catalogs and so forth. But today's project, specifically what we're going to be working on, is an elevation screw. And you see right here this screw that is in here, and this is basically used, there's a crank that will mount up on the top of this, and it will allow the operator to turn this crank and adjust the thickness of the feed rollers for different varying thickness boards that would be fed through this machine. The thread on this piece is machined at an odd size. It's actually 3/4 inch would be the rod diameter, but it's 8 threads per inch. Standard coarse thread for a 3/4 inch thread would be 10 threads per inch, but on this we're going with 8 threads per inch, and that's the way it was originally. And the reason is because this is a woodworking machine, and woodworkers tend to think of dimensions in fractions rather than in decimals like a machinist might. So they're thinking in 1/8 of an inch. So as you're adjusting this, one revolution of the crank would actually adjust the height of this 1/8 of an inch via 8 threads per inch would be 1/8 of an inch per rotation. And again, in fractional standpoints, that just makes it a little bit easier. If you wanted to go a 16th, you would only do half of a turn. If you want to do a 32nd, you would do a 1/4 of a turn. So it was fairly easy to be able to calculate how far you need to turn the wheel based on where you are now, where you want to be. So it's 8 threads per inch, which is again an oddball size. I got lucky though, and I was actually able to find a tap that is 3/4 8, which again is a very unusual size. And to make it even more rare, the threads on this are left-hand threads, so that you would turn this crank clockwise to raise it up. So these are left-hand threads, but again, I got very lucky and found a 3/4 8 left-hand tap of all places on eBay, brand spanking new, for hardly anything at all. I got very lucky to find that. The reason I got lucky is I need to clean these threads out that were on the original one, and I actually have to machine a new bracket for another place that we'll be working on later that will have to be tapped to that. I'm going to cut these threads on the lathe. That would be the easiest way to do it, particularly with an oddball size. Finding a die for that would be next to impossible, or if I had to have one made, it would be quite expensive. And it's fairly easy to cut threads on the lathe, so we're just going to cut these on the lathe. I did make a nut here that I use as a test fit on the lathes, so that as I'm cutting these I can check that out. And all I did was just take a piece of hex and drilled a hole in it and tapped it out using that tap that I already have, and that will allow me to be able to test the fit on the lathe to know whether it's going to work over here. So now that you see what we're after making, let's get in here and get started on the project. I made this one earlier in the week, and we're going to start on the second one. Will be the one I shoot the video on today. We're inside now at the lathe and getting ready to get things set up to do this. I'm going to be using a inserted carbide insert tool that's actually set up for doing left-hand threads to cut these with. It's a fairly coarse cut, so this will make it go a little bit easier. I actually had this, I bought this this tool for another job quite some time ago. It was also a left-hand thread job, and it's going to work very good for this, so I'm not going to have to do any special grinding or anything. I really like this because the front of this cutter is actually set at just a little bit of an angle to really cut clean threads. So this is set up truly for left-hand thread cutting, and we'll just put this right on the lathe and be ready to go. There are a couple of things that we need to do before we get started on here to get the lathe set up for cutting threads, and specifically left-hand threads. First off, I have my quick change gearbox on this lathe, and I have it set to 8 threads per inch, which is what we'll be cutting, and then also I have all my other levers associated with this so that my lead screw will be turning the right speed to cut 8 threads per inch. Now for left-hand threads, normally if we're cutting right-hand threads, but we need to make an adjustment here on the lathe. On this lodge and shipping lathe, there's a lever right here. Right now it's set in right-hand threads, and this is basically going to adjust the direction in which the lead screw is turning that will be used to cut the threads. And we're currently set in right-hand threads. We flip it down, and now we're in mode for left-hand threads. So just that easily, we're changing basically the direction in which the carriage will travel when I engage the half nut for cutting threads. To start cutting threads. I have my thread cutting tool in here. Notice I have my compound set backwards from normal. Again, we're cutting left-hand threads, so we'll actually be moving, the carriage will be moving out rather than in. And because I always want to be cutting on this leading front edge of my cutter, I have the carriage set to the same angle as this right here, so that I'm always cutting across this front edge of the cutter. So we're moving in and out like this. We'll be feeding out this way. I'll start out by taking a real light test cut and checking that with my thread gauge to make sure that we are truly on 8 threads per inch, and then we'll start cutting this out. I move my tool in until I'm just touching, and I set my gauge to 0, my dial to 0 on the cross feed. I'm cutting even numbered threads, 8 threads per inch, so I can engage my thread dial on any line on here. So either on the numbered lines or in between, and that's again going according to the recommendations of my lathe. We let it come around to a number on that dial, and we engage. Get to the end, disengage, pull the cross slide out, carriage back over to the starting point. We'll go back into 0 again on the dial, on the cross feed dial, and then we'll feed in on the compound side. Before we do that though, we're going to check our thread pitch. Perfect, 8 threads per inch. setting oil on there. I'm going to feed that in about 5/1000ths of an inch to this first pass on the compound, and then we'll engage the cross line. Engage the half nut. We're getting down pretty close to the final diameter here, the final cut. Probably just a few more passes and we'll be there. We'll start checking this here in just a minute to see exactly where we're at and how many more passes we need to go. Right now I'm only taking about 1/1000 of an inch per pass on the compound slide, and that's taking a pretty wide chip as it's cutting across here, because this is, again, a fairly coarse cut that we're making. Starting to fit on there, but it is just a little bit tight yet, so we're going to make probably another pass or two and check it again. Pass will be just a spring cut. I'm not adjusting the cross slide to setting it back to 0. You just make a clean swipe to make sure we're getting a good, even cut all the way across. Fit. We've got this piece machined now. Now we're going to do a test fit on the machine itself. Put it in here. Remember, this is left-hand thread, so it turns backwards. Yeah, that fits real good. I'm very happy with that. Alright, we have both of these elevating screws now done as far as the threads cuts, but now we've got some further machining. There's a sprocket that will go on each one. There's a chain that goes between the two pieces here. So there'll be a chain that goes from this screw to this screw, so when you crank one, it will turn them both at the same time, at the same speed, in the same direction, up and down. So we're going to have to cut a keyway in here, put that sprocket on, and then mount it all into the piece that goes across the top here that holds it in place. And on one side we've also got to machine a square shank for the handle to fit on. Now that we have the elevation screws turned to the proper thread, the next step is we need to put a keyway into the top of this because there will be a small sprocket that fits down over the top of this shaft that will need to key onto this so that it can turn. So we're going to be cutting a woodruff key, a slot for a woodruff key. We're using a 3/16 thick key that's on a 3/4 inch diameter circle. I have a woodruff key cutter that we'll be using to do that, and we actually have it set up here in the mill ready to go. We'll show you the process for cutting a woodruff key. Before we get too deep into this, I want to show you the setup that I have that I'll be using. So instead of putting the actual elevation screw in a vise, we're just going to bolt it down or clamp it down directly to the table, and we're going to put it in one of the mill slots. This is just a little shortcut that you can use to save a little bit of time. Anytime you're putting a round stock on a table, and you need to get it set parallel to the table itself, because these mill slots are cut parallel on the table, and because this is round, they fit right in there. You can just plop it right on the table and just clamp directly into those slots, rather than having to worry about setting up a vise and getting it all lined up perfect. This is about as accurate as you can get. So I've got this bolted down here or clamped down here. I also put a stop on this end over here, which is just a little piece of metal. It's clamped on there. And the reason I did this is I had two of them to make, and they're pretty much going to be built exactly the same way. So instead of having to set everything up again, I can just, when I get through with one, I can take it out and just plop the next one in, and I should be set up and ready to go on it as well once I get my depth and everything set. So now the next thing we need to work on is we need to get this cutter centered into the shaft itself. And to do that, we're just going to use some math. It's pretty straightforward. I know that the diameter of this rod is 3/4 of an inch. I know that I want this to be in the center of that rod, so I just take half of that diameter, which was half of 3/4 is 3/8, and 3/8 is 0.375. I know that my cutter is 3/16. 3/16 is 0.1875. So what we'll do there is we'll again take half of that, which is 3/32, 0.937 thousandths. I added not 0.93 or 0.0937 to the 3/8 0.375. Do the math. I'm just going to round this to the nearest thousandth, and I know that it needs to go down 0.469 inches. So what I'll do is we'll take the cutter, we'll just touch off to the just barely let it touch the top here, move the table out of the way, and then I will crank the table up 0.469 inches, and that cutter should be centered directly onto the shaft. And then as far as depth goes, again, I will come in, I will touch off to it until I just barely get my first cut on there. And I know that this keyway needs to be cut 200 thousandths deep, and for that I'm going to use the digital readout on my mill to go in 200 thousandths, and we'll just cut it nice and slow and get it in there to that depth. Got you zoomed in close here where you can see what's going on. I turned the mill on. I have this running pretty slow. Right now that's running about 75 RPMs. That's one thing with these woodruff key cutters. You do want to run them rather slow. If you run them fast, you're just going to burn them up. This isn't a race, so we're just going to go nice, slow, and easy. I'm going to take the table, we'll lower it down a little bit. We'll pull this in here until we're right above that, and we're just going to raise the table up until we get a chip off the top. Okay, I'm touching off right there. You can see the little mark, it just barely scratched the top. So that's a 0, and from there I'm going to set my gauge over here, my dial on my elevation on the Z-axis to 0, and now I'm going to crank this up 469 thousandths. So make sure that's over far enough. 100, 200, 300, 400, and 50, 60, 69 thousandths right there. So that should have that cutter set to the proper depth so that it'll be in the exact center. Now we're going to pull this in again until we just barely touch off. I'm touching now, so we're going to 0 our DRO, digital readout, and from there we'll go in 200 thousandths, put some cutting oil on this, and again, just take our time and cut. So that's about 10 thousandths, 20, 30, 40, 50, 60, 70, 80, 90, 100, 150. $175. About 200 thousandths deep right there. Okay, we pulled this off the mill now. I took it over to the wire wheel, just ran it across there real good, and just deburred it. We put that in there. Fits very nice. Now let's get our sprocket. Perfect. We're just about through with these elevation screws, and there's only really one step I have left, and that is on one of the screws we're going to need to be able to fit this crank handle on so that we can crank that screw up and down. and this has a 5/8 inch square shank that'll fit over. This is 3/4 of an inch diameter, so what we need to do is mill roughly a 5/8 inch square on here, and it won't be exactly square because we don't really have enough material to take off, but we can get enough of a flat side on these that it'll fit on that and engage pretty well. So to do this is I'm just going to do a quick setup again. We're just going to come down here, touch off to this. Because we're going from 3/4 to 5/8, we need to take half of that thickness off each one, which will be a 1/16 of an inch. So after I touch off, I will raise my table up a 1/16 of an inch, and then we'll just use this fly cutter to cut across there. And then I'm going to use this, it's actually a V block, but it's square on the side. So I will turn this over. The side that I just previously made flat, I will register up against that, clamp it back down, do the process again, and we'll do it on all 4 sides until we have a square shank. And we won't move the table in this direction at all once we get it set. That way we'll have a nice even shoulder all the way around. At least that's the plan. Let's give her a try. We have the cutter going about 250 RPMs, and right now I'm just going to raise the table up until it just touches off. Alright, we're going to call that 0. We'll move that out, and now we're going to raise up 1/16 of an inch, which will be 0.0625. $62,500. And we'll just feed the table in this way. I've got a mark on here where I want this shoulder to be, and I'm not quite there, so we're going to just get that pretty close. It's not a critical measurement. We're going to get as close to that mark as we can. There's my line. I'll lock my table back down. All right. Loosen that up. Get that squared up on that side. I have a stop on this end, if you remember earlier, so that's going to help me keep this lined up exactly right. And clamp this back down, and we'll make the next cut. one more cut. All right, before we pull this off the table, we're just going to double check, make sure we are indeed 5/8. The 5/8 will be 0.625, and I'm at 6/200, so that's perfect. We're going to call this job done. We have our piece made now. You see the square shank on the end. We have our keyway there, and of course the 3/4 H threads. Quick test fit here, and my handle is sliding on here. It is a little bit stiff, but this handle, actually the square hole in here was cast in at the foundry, so it's not a perfect square. I can see there's some irregularities in there. I'm either going to run a square broach down through there, take some files and clean it up so that it will fit on here. But I'm definitely close enough that we should be able to get this to work with a little bit of work on the hole. And now to show you how it all goes together. So we'll take the key, tap it in place here. Take the sprocket, go down on shaft, tap that in place. A little stiff, but it goes right on. There's a set key in here, so we'll tighten that on place, which will tighten that onto the keyway we just broached or cut. This will slide up through the bottom here. I do still have to turn a collar that will go across the top here, and I'll probably pin it on with a tapered pin, and then our handle will fit onto the top here, and then that will turn to crank that sprocket, which will be connected to a almost identical setup to the other side, except it'll be exactly like this, but it won't have the square part on the top, since we'll only adjust it on one side. That'll just be cut off flush, and it'll just have a collar on the top of that side. So getting very close on this. Like I said, just have to put those collars on and we should be ready to go. got a little more wobble out of that than what I wanted, but we're actually going to turn this down to final diameter on a later step, so I should still have enough meat as long as that hole is pretty close to being in a truly 3/4. We'll check that out here in a minute. Check the fit on this. That feels pretty darn good. I can actually feel a little vacuum when I pull it out, so it's a good tight fit. Alright, we're going to face off the front side of this, and then we'll use our parting tool to cut it into the length that we need for the two pieces. Parting tool on now. We want these to be 1 inch long. We have the collar and the shaft mounted in a vise on my milling machine now. We're going to drill a hole in the center of this that we will then use a tapered reamer to ream out for a tapered pin that will go in there and hold that collar in place. But I want to get it right in the center of the shaft. So I have a edge finder set up here on the milling machine, and we're going to use this to find the exact center of this shaft. So this is in here. I just knocked this off center, so just wobbling a little bit. And what we're going to do is we're just going to bring, using the milling machine, we're going to bring that over right to the edge, and we'll watch until it jumps over. When it jumps over, right there, I'm now right on the edge. And I'm going to come up here to my digital readout. I'm going to zero that out. And usually after I zero it one time, I will just do it a couple more times. And okay, I'm within about a 1/2 thousandth of where I was last time. I'll re-zero that again. And let's just do it one more time. Yeah, we're right on the money. So from here, I turn it off. I'll raise this back up, out of the way. Now I'm over here on the digital readout. I'm at 0. And I need to find the center of this, so we'll just do again some math. I know that the diameter of my edge finder is a 1/2 inch. So first thing I'm going to do is get it so instead of being on the edge of that, I have the center of the drill chuck here on the edge. And to do that, I'm just going to move over half that 1/2 inch. It'll be 1/4 inch. It'll be 250 thousandths. 100, 200, and sneak up on it. Alright, so we're at 250 thousandths. And right there, I'm going to come in here and I'm going to zero this out again. And now I need to move to the center of the shaft. The shaft is 3/4 of an inch. Half of that is 3/8 of an inch, which is 0.375. So I'm going to move again over 375 thousandths. Right there. And that should be the exact center of my shaft. And again, I'm going to zero that out so that I know I'm right there. Okay, to do this job, to put this taper pin in, what we're going to do is we're just going to start out with the center drill, and we're going to drill a starter hole right here in the very center of that collar. Next, I'll come through with a drill bit. 5/32 I think is what I have determined the hole need to be for that reamer. We'll drill that all the way through both the collar as well as the shaft itself, and then using the tapered hand reamer, we'll come in and we'll ream that taper out for the taper pin to lock that in place. Got our 5/32 drill bit in. Alright, we moved the table out a little bit to give us some room to work here. I have my reamer in just a tap wrench, and we'll get started. Our starter hole is kind of close to start with here. A little bit different light on there. It's going to take us just a little bit to get it going straight down that hole. Yeah, it's going better now. I will stop and clean that reamer out as we go down. Just makes it cut a little bit cleaner. Also put some oil on here. Alright, the reamer is all the way through, so let me check the fit with the pin. Okay, we are getting close, but it still needs to go a little deeper. Perfect. Okay, you can see the pin is tapped in there nice and tight. The pin's just sticking out a little bit on either side. And we're going to actually go over to the lathe now, and we'll turn this whole outside diameter to the correct diameter on the shaft itself, and at the same time turn the pin down to the proper size. We have the part chucked up in the lathe now. We're going to turn the pin down flush with this, and also turn this diameter of the collar down to 1.25 inches. We're at about 1 3/8 right now, so we're just going to go ahead and turn all that down. We have the screws finished now and now installed in the headpiece with the sprockets. As you can see, the chain is wrapped around them. It goes from one sprocket over to the other side, so that when you turn one side, it turns both of them at the same time at the same speed. Back here is just a little wooden cover that has a trough cut out in it, and we'll turn this over. It'll go down over the two shafts into that hole, and that will protect the chain. There's actually some holes in the other side where you can put some wood screws in there to attach that piece in. So we're just about got this ready to go on the machine. The adjustment screws are now mounted on the machine, built into the cross piece here. So as you saw before, we got the chain and the gears up underneath here. There's a wooden plate up underneath the bottom here to protect all of that working. These screws go down into the cross feed piece here, and when you crank, it raises and lowers both sides at the same time to adjust the thickness of the board that you're running through the machine. I had somebody on the forums ask me about the expansion gears, why these two were geared here. And that's just as these rollers open up, it keeps all the gears in line with one another. And with that, we'll call this part of the job done and move on to the next step.